we're going to solve a system of two linear equations by substitution. So everything I'm about to say is summarized on this slide. But what we're going to do is just dive right in. So as I mentioned, there are two different ways you can solve 2 by 2 systems, two equations, two unknowns. One is substitution that we'll look at first, and the second is elimination. I'd like you to try both because they both have their place. In some situations, substitution really is the easiest way to go, but there are many scenarios where elimination is faster. The other pro to elimination is that it is a much, much better way to solve a 3 by 3 system. So if we can get comfortable using elimination for 2 by 2s, it makes the work of solving the 3 by 3 much easier. You can absolutely solve a 3 by 3 using substitution as well. But in my now 6 years of teaching this course, or this module within a variety of courses, there's twice where someone's gotten the right answer using substitution. The problem with it is that it just leaves us open to lots of places to make small errors. Okay, substitution and elimination. Here goes. Well, first I'm going to label the equations. Before we do anything else, let's make sure we all know what we're talking about. And then I'm going to look at what's going on in equation 1 and equation 2. What I'm looking for is for one of the variables to have a coefficient of 1. And in this case, it's the x in equation 1. So I'm going to choose that variable to isolate. So from equation 1, I'll just write from 1, I'm going to isolate the x. So I have, let me write the whole thing out. I'm going to isolate the x, so to move the negative 5y, to move that term to the other side, it becomes positive, sure, but it's really moving because I'm adding 5y to both sides. So if I add 5y to the left-hand side, it becomes 0, and here I have negative 34 plus 5y. They're not like terms. One doesn't have an x, or rather an x or a y, and one has a y, so I have to leave it there. So I haven't learned a whole lot, but I have learned that x in terms of y is equal to negative 34 plus 5y. So this is the value of x written using y. So now I'm going to substitute my newfound fact into the other equation. So I'm going to substitute the fact that I now know that x is equal to negative 34 plus 5y into the other equation. So it came from equation 1, so it has to be substituted into equation 2. Equation 2 is 2 times x, but I know that x is equal to negative 34 plus 5y. So I'm going to drop that in for x. So I have negative 2x minus 5y is equal to negative 28. Now I have here one equation, and it's only got a y, well, 2 y's in it. It's only got one unknown. One equation and one unknown, we solve those all the time. So sometimes we'll have done the factoring module before we do this one. So you may be ahead of the game a little bit if you're comfortable solving equations, or you've done that module in a different context. We'll just very briefly go over tips for solving equations. None of these are going to be too complicated. The rule of thumb for solving equations is to undo any groupings first. Groupings could be fractions, they could be round brackets like these, they could be square brackets. We want to make sure whatever they are, we undo any groupings. So we want to get rid of these brackets, so we'll use distributive property as our first step. So 2 times negative 34 is negative 68, and 2 times 5y is, of course, 10y. And then I'll just write down the rest of the equation. So step 1 is always to remove any groupings. Step 2 is to collect any like terms that are already on the same side. So I'll write a lot of steps for this equation, but you can start cutting these down if you're comfortable. All right, so 10y minus 5y, those are like terms. We get to subtract those. Now I want to keep all the terms that have y. So this is why we talked about terms and factors extensively. I want to keep all of the terms that have y's in them on one side, and all of the terms that don't have y's on the other side. So I'm going to add 68 to both sides to move this negative 68 over to the other side of the equation. So we have 5y is equal to negative 28 plus 68. In other words, 5y is equal to 40. Once you've isolated the term with your unknown, now all you need to do is get rid of the coefficient of 5. Because 5 is being multiplied by y, we get rid of it by doing the opposite, by dividing. 5 divided by 5 is 1, so I have y is equal to 8. I'll speed up that process a whole lot. It probably won't take you this many steps to do it, but just as a warm-up exercise, here we go. So I do see some questions or possibly some answers. I'll get to those in just a moment. What have we learned so far? We have learned that y is in fact equal to 8. So we have one of our unknowns. As soon as you have one of your unknowns, you're basically done. You're going to substitute your useful fact that y is equal to 8 into either equation 1 or equation 2. It does not matter which one you use here. Equation 1 is a little simpler, so I'm going to choose that one. So I'm going to say, let's substitute y is equal to 8 into equation 1. So that gives us, let's get rid of this rather confusing arrow. Gives us x minus 5 times 8 is equal to negative 34. So we have x minus 40 is equal to negative 34. Moving that 40 to the other side by adding 40 to both sides gives you x is equal to 6. And there we go. We know the xy coordinate where those two intersect. The best way to write the answer would be to say that xy we now know is equal to 6, 8. If this was a written test, I'd say as long as you try to highlight where your answer is, x equals 6, y equals 8, I'm perfectly happy with that. Just a quick recap, what did we do? We looked at our set of equations, and we chose one variable out of one of the equations to isolate. I chose the x in equation 1 because it has a coefficient of 1. If I have a coefficient other than 1, I'm going to end up with fractions, most likely. So that's why I prefer to choose one set of coefficients of 1. Let's do just one more, and this time I'll let you get started. So take a minute to look at this question. We'll label it equation 1 and equation 2, and tell me where those two equations intersect. Okay, looking at the two equations, we may not have done this the same way, but I'm going to tell you how I would solve this. I'm going to look again for the variable that has a coefficient of 1. So I'm going to choose as my first step to isolate the y in equation 2. So that gives me y is equal to positive 5x minus 3. So right now I know what the value of y is in terms of x. So I'm going to substitute my new knowledge that y is equal to 5x minus 3 into the other equation. So this time I have to substitute it into equation 1. So I have 3 times x minus 8 times y, but I now know that y has a value of 5x minus 3, so I'll throw that in there. And that's equal to negative 3. One equation, one unknown. We can go ahead and solve that. Again, I'm going to open up the brackets first. So I have 3x minus 40x plus 24 is equal to negative 3, just using distributive property there, minus 37x. This guy here. And now I'm going to move this 24 to the other side. Subtracting 24 from both sides gives me 0. I'm going to finally, as my last step, divide both sides by negative 37. 0 divided by anything is still 0. So I think I've redeemed myself and discovered that our first unknown, my first unknown, maybe you found y first, is x is equal to 0. And now I'll substitute x is equal to 0 into either equation 1 or equation 2. You know what? I think it's easier in equation 2, so I'm going to choose that one this time. So there I've got negative 5 times x, so negative 5 times 0, plus y is equal to negative 3, so y is equal to negative 3. 0, negative 3 is our final answer. All right, that is substitution. Again, it's easiest if at least one of my variables, if I have just even the one variable that has a coefficient of 1. Otherwise, it gets a little bit trickier. Again, I've written this all out in words, but we're going to explore it with an example. You're very likely looking at this system and saying, well, I've got a coefficient of 1 for x. It looks like it's pretty easy to use substitution. And I don't disagree. But it happens that for this system, it's actually much easier if I just go ahead and use elimination and play with them. Watch what happens. The key to elimination is that you want to add or subtract the two equations with the goal of eliminating a variable. So if I take equation 1 and I add equation 2, so I've got x minus 3y is equal to 6. I'm just going to rewrite them so I can circle and scribble on them and not ruin the originals. Equation 1 and equation 2. What I mean by adding the two together is I'm going to add everything on the left-hand side of the equal sign and everything on the right-hand side of the equal sign. Think of it this way. If I say I'm going to add equation 2 to equation 1, that's like adding 3 to the left side of equation 1 and to the right side of equation 1. Except only one of them is actually going to look like 3. The other one is going to be 2x plus 3y. But 2x plus 3y is equal to 3. So if I add 2x plus 3y to the left-hand side of equation 1, and I add 3 to the right-hand side of equation 1, I still haven't changed the value of equation 1. Remember that in an equation, it does not matter what I do to it as long as I do exactly the same thing to both sides. So those are tools we didn't have when we were just looking at snippets of equations, when we were just looking at expressions. Okay, when I add the left-hand side, I could write it this way. I could say, well, I have x minus 3y, and then I'm going to add 2x, and I'm going to add 3y. And that gives me x plus 2x and negative 3y plus 3y. I'm going to back up because that's not the nicest way of writing this. Because I've already organized the two equations so that the x's are lined up and the y's are lined up, I may as well add them that way. Because I know I'm allowed to rearrange terms as long as I'm mindful of the signs. So here I have x plus 2x. X plus 2x is 3x. Negative 3y plus 3y is 0. And 6 plus 3 is 9. So we've eliminated y. We added the two equations together, and the y is gone. Now we have one very simple equation that only has one unknown. Dividing both sides by 3 gives me x is equal to 3. I already have one of my unknowns. Go ahead and substitute x is equal to 3 into either of the original two equations. Here I'm going to recommend equation 1. That gives me 3 minus 3y is equal to 6. One equation, one unknown, those are easiest to solve. Move the 3 to the right-hand side by subtracting 3 from both sides gives me negative 3y is equal to 3. Dividing both sides by negative 3, so the negative 3's cancel, gives me y is equal to negative 1. So the solution here is the coordinate pair 3, negative 1. That's where those two lines intersect. For this equation, for this system of equations rather, elimination is hands down the fastest way to do it. The reason it works really well is because looking at the y's, I have a y with a coefficient of negative 3 in one equation and a y with a coefficient of positive 3 in the other. So when I add those two together, they disappear. So that's what I'm going to look for each time. And again, if I'm allowed to add two equations together, I'm also allowed to subtract two equations. The one thing that we haven't talked about here is how to do a check. So what does it mean that xy is equal to 3, negative 1? Well, that means that if I substitute that answer, xy is equal to 3, negative 1, into equation 1, the left side should be equal to the right side. So what I'm really doing is I'm going to say check in 1. The yellow sub xy equals 3, negative 1 into 1 is really what I'm going to do. A shorthand for that is let's check that answer in equation 1. So here we have x, so x is equal to 3 minus 3 times y, but y is equal to negative 1. That should be equal to 6. And is it? Yeah, 3 plus 3 is equal to 6. So you'll see notation like this sometimes, left side equals right side. A visual check is fine. I tend to just throw a check mark next to it. What does that mean? It means the point 3, negative 1 satisfies equation 1. It is a solution for equation 1. So we can find 3, negative 1 on line number 1. Can we find it on line number 2? It's absolutely possible that we did one step correctly and then made an error. So I do want to make sure I check in both. So we've checked it in equation 1. I want to now make sure I also check it in equation 2. So we have 2 times x, and x is equal to 3, plus 3 times y, and y is equal to negative 1, should be equal to 3. So I have 6 minus 3 equals 3. Yeah, absolutely, 3 is equal to 3. The point 3, negative 1 is also a solution to the second line, so it is also, or therefore, it is a solution to the system. Right? If it fails one of those 2 checks, then you found a point on one of those lines, but you haven't found the solution to the system. That's what the check is telling us. We're going to use exactly the same strategy here. Again, I see a coefficient of 1 for the x in equation 1, but let's practice elimination. It's probably still faster. How are we going to eliminate the variables? If I just take those 2 equations as written and add them together, it would give me x minus 3x is negative 2x, 4y plus 5y is 9y, and 8 plus 10 is 18. Congratulations, we've written a new equation, but does it tell me anything new? No, it still has 2 unknowns. So while this equation is true, it's valid, it's not helpful. Why did addition work last time? Again, it's because we had a coefficient of positive 3 in one equation and negative 3 in the other for the y. So it's not quite as easy here. If I notice here, I have a negative 3 coefficient for the x. If the coefficient for x was positive 3 in equation 1, this would all work very nicely. Well, that's okay. I'm allowed to do that. I'm allowed to just take equation 1 and do whatever I want to it, as long as I do the same thing to both sides. So I'm going to choose to take equation 1 and multiply the entire equation. That's a multiplication sign, not an x there. Sorry for the sloppiness of Zoom. Multiply that by 3. So I'm going to take all of equation 1 and multiply it by 3. You can think of this as taking the left-hand side and multiplying it by 3, and taking the right-hand side and multiplying it by 3. It's just a little tidier to write if I put brackets around the entire equation. In any case, 3 times x is 3x, 3 times 4y is positive 12y, and 8 times 3 is 24. And I'm going to call that equation 3 just so I can refer to it, because it's equivalent to equation 1. If I graphed it, it would look exactly the same. But I'll call it equation 3 so we know which combination we're looking at. Okay, let's rewrite equation 2 underneath. Equation 2 is negative 3x plus 5y is equal to 10. We haven't altered it, so I'll continue to refer to that one as equation 2. Now we're going to add those 2 together. So now I'm going to add equation 3 and equation 2. And this shorthand, if you're, leaving rough notes for yourself or for me, is really helpful to see which 2 equations are you adding here, what's going on. So I've written the plus sign, but I've also indicated using the circled numbers what I'm trying to convey. 3x minus 3x is 0. 12y plus 5y is 17y, and 24 plus 10 is 34. Dividing both sides by 17 gives me y is equal to 2. And so as soon as I have one of my unknowns, I'm going to take that unknown and substitute it into either of the original 2 equations. Because equation 1 is simpler, I'm going to substitute it into equation 1. So then I have x plus 4 times y, so 4 times 2 is equal to 8. X plus 8 is equal to 8. X is equal to 0, moving that 8 to the other side. The faster I write, the worse it gets. I apologize. I will try to summarize. So the final answer is x is equal to 0, 2. So one thing I noticed right off is that substitution is really the wrong answer here, because while I absolutely can isolate x in equation 1 or y in equation 1, or x in equation 2, or y in equation 2, neither of them is a coefficient of 1. So here's the kind of thing that happens. So for example, if I wish to isolate x in equation 1, so I'd have 5x is equal to negative 5 minus 8y. Start by moving this 8y to the other side. Dividing both sides by 5 gives me either x is equal to negative 5 minus 8y all divided by 5, which is the same thing as negative 5 over 5 minus 8y over 5. So at least negative 5 over 5 would simplify. So I'd get x is equal to negative 1 minus 8/5 y, or 8y over 5. But now I have to substitute that into the other equation. It's a lot of work. Don't do that. That's why we're using elimination. It allows us to use all whole numbers. All right. So we need either the x's to have the same coefficient or the y's to have the same coefficient. The other thing that's really handy is if either the x's or the y's have the same coefficient but in the opposite sign. So one thing I can do, I can imagine taking the 5x and the 3x, and I notice I can turn both of them into 15s. If I take equation 1 and I multiply through by 3, I would turn the coefficient for x into 15. I do the same thing if I take equation 2 and multiply through by 5. It doesn't matter that I'm not doing the same thing to equation 1 and to equation 2. It only matters that I do the same thing to the left side and the right side of a single equation. So take equation 1 and multiply through by 3. So equation 1 multiplied by 3. That gives me 15x plus 24y is equal to negative 15. Here's one to be really careful of. Don't forget to multiply both sides of the equation by the 3. That's one of the most common places I see errors. And then the second equation, because I've decided I'd like the coefficients for x to be 15. Maybe you made a different decision. That's completely okay. A common question here is, well, why 15? Well, why not? It is the smallest common multiple. That's the best reason for choosing it. All right, 5 times 3x is 15x. 5 times negative 5y is negative 25y. And all of that, 5 times negative 3 is equal to negative 15. I'll call that equation 4. Okay, so now I've got 15x and 15x. Hopefully you've noticed that if you simply add those two equations, so if I decide I'm going to add the two of them, I'd end up with 15x plus 15x is 30x. It doesn't eliminate. And here I have 24y and negative 25y. Those aren't the same, so they won't eliminate either. That's okay. So I'm not going to use addition here. I'm going to instead take all of equation 4 and subtract it. So it looks like this. 15x minus 15x, that's equal to 0. But now be careful here. Positive 24 minus negative 25. 24 minus negative 25 is positive 49y. Really easy place to make a small error. So that 0 is irrelevant, but that positive 49 is important. And on the right-hand side, negative 15 minus negative 15, that's like negative 15 plus 15, so that's 0. It actually doesn't matter that 49 is a bit of an unwieldy number. When I divide both sides by 49, I get y is equal to 0. So pretty tidy. So that's an example where instead of adding the left side and the right side, you subtracted the left side and the right side. There's one other way you could have done this. Instead of using subtraction, and I personally don't use subtraction a lot. I see a lot of mistakes with it. It's very easy to make plus minus mistakes. It's very easy to take negative 15 and decide you're going to suddenly add negative 15. So you get 49y is equal to negative 30. That's messy. Let's not do that. So the other way I could have done it is taken maybe equation 1 and multiplied through by negative 3. So if I had negative 3 up here, that would give me negative 15 minus 24y is equal to positive 15. So now I could have added the two equations. So generally what I try to do is I multiply, in this case, both our x's at positive coefficients. I'm going to multiply one by a positive value and one by a negative value. And then I can add the two equations. Y is equal to 0. So we should go ahead and substitute that fact, y is equal to 0, into either equation 1 or equation 2. So let's do equation 1. So we have 5x plus 8 times 0. And if you don't want to write out 8 times 0, if you just realize that's equal to 0, that's okay. You're allowed to take all the shortcuts you like as long as you're comfortable doing them and you don't make an error. And we find that x is equal to negative 1. If I substitute negative 1, 0 into equation 1, I should get negative 5 equals negative 5. If I substitute negative 1, 0 into equation 2, I should get left side equal to negative 3.